Hey, so let's go ahead and look at complex fractions. So complex fractions really just means fractions over fractions. And there's two, well, probably more than two, there's a few ways to do these. We're going to look at two of them. We're going to look at one of them here and one of them in the next one. So if you get this one, skip the next one. Anyways, let's look at the operations that's going on. I got 1 over x plus 3 minus 1 over 2x plus 6 divided by, meaning a huge fraction, right? Huge fractions is the same thing as divide. So divided by 3 over 2 minus 4 over x squared minus 9. Means I got the operation of combining, which we already know how to do. That's my operation that's happening in the top and in the bottom. And I got the operation of divide, which I already know how to do. So if I can just do both of those operations, which I already know how to do, then this shouldn't be that bad of a problem. So we're going to start by combining. I have two things in the top, so I need to get those down to one thing before I can go ahead and divide. Same thing at the bottom. I got two things, I need to get those down to one thing before I can divide. Mainly, if you remember order of operations plus PEMDAS. Well, please excuse my dear Aunt Sally. Wait, no. Parentheses, exponents, multiplication, division, addition, subtraction. You do parentheses first, then exponents, then multiplication and division, then addition, subtraction. So why am I not dividing first? Main reason I'm not dividing first is because since I have two things on the top, I'm saying that those two things belong together. I put those in invisible parentheses. If I wanted just one thing in the top, I would have just put one thing in the top and said, well, that thing can be divided. Okay, so we always need to combine them first. So to combine them, I'm going to go ahead and find a common denominator. So I'm going to factor as much as possible. X plus 3, 1 over, and 1 over. Second one's not a quadratic, but it can be factored. I can pull out an x. So 2 times x plus 3. And I can write this as a single fraction. I just need to find a common denominator. So you got the x plus 3's in common. Second one just need to be, the first one would just need to be multiplied by 2. So 2 minus 1 over 2x plus 3. Second one didn't need to be multiplied by anything. So 1 over 2x plus 3. So I have my numerator. Let's look at my denominator. I could factor. Looking at this though, I can tell that there's no sense in me factoring to find a common denominator. If I factor x squared minus 9, I'm going to have x plus 3, x minus 3. There's going to be nothing in common with that too. So there's no sense in me factoring. I might as well just find the common denominator from the original fractions. So minus, and then I got 4 over x squared minus 9. So they have nothing in common, right? That means my first fraction is going to need an x squared minus 9. And my second fraction is going to need a 2. Now they look the same, so now they're common denominators. So my common denominator would be 2x squared minus 9. Numerator, I would have 3x squared minus 27 minus 8. So 3x squared minus 35 over 2x squared minus 9. Okay, so again, this is one big fraction. This is 1 over 2x plus 3 divided by 3x squared minus 35 over 2 times x squared minus 9. So I'm going to write this as division. I'm going to write 1 over 2 times x plus 3 divided by 3x squared minus 35 over 2 times x squared minus 9. When I'm dividing fractions, I already know I need to flip the second one and multiply. So 2 times x plus 3 times, flip it, 2, and I know when I'm dividing, I want to simplify. Simplify again means factor. This time there is a reason for me to factor the x squared minus 9, so I'm going to. So I'll get x minus 3, x plus 3. Bottom I'll have 3x squared minus 35. I could not factor that, I tried. X plus 3's are going to cancel, 2's are going to cancel. So I'm going to get on the top 1 times x minus 3 is just x minus 3. And then on the bottom, just 3x squared minus 35. And that's it. Can't do anything else, so my complex fraction is down to one single fraction. Try this again with another one. Say we have 3 over x minus 1 minus 1/5. So I know real quick I'm going to have to write that as a single fraction. I'm going to try to factor. I can't factor, so I'm going to try to find a common denominator. I know the first one, they have nothing in common, so they're going to need each other. So the first one is going to need the 5. The second one is going to need the 3x minus 1. So I'm going to get on the top 15. Don't forget this minus is going to go with that 1. Minus 3x plus 1. On the bottom, I'm going to have 5 times 3x minus 1. Combine like terms, minus 3x plus 16. 5 times 3x minus 1. Okay, so let's look at the denominator. Denominator, 2 over 15x minus 5 plus 3 over 10. This one I can factor. So I'm going to factor the first fraction, 2 over, I'm going to pull out a 5. Let's see, that'd be 3x minus 1. Second fraction is just numbers, so I'm not going to factor it. I'm going to try to, again, find a common denominator. So let's see. The first one here is missing a 10, but it does have a 5. So I don't actually have to multiply that by a whole 10. I know I need to get it to look like a 10, but it has the 5, so I really just need to multiply it by a 2. If I multiply it by a 2, 2 times 5 would give me 10. So these are now the same. Second fraction is missing the whole thing. It is missing 3x minus 1. So I'll multiply it by 3x minus 1. Okay, so now I have 4 plus 9x minus 3 over 10 times 3x minus 1. Combine like terms, 9x plus 1 over 10 times 3x minus 1. Okay, so I got my numerator. My numerator is negative 3x plus 16 over 5 times 3x minus 1 divided by, I'm going to write this as division now, not as a big fraction, 9x plus 1 over 10 times 3x minus 1. Again, I know division means I flip the second one and multiply, so I'll keep the first one the same, making sure I can't factor it anymore. I can't. Minus 3x plus 16 over 5 times 3x minus 1. So I'll flip the second one, and I should get 10 times 3x minus 1 over 9x plus 1. So let's see if I can simplify. 3x minus 1 and 3x minus 1 will cancel out. 5 and 10 doesn't cancel out, but 5 goes into itself one time and 10 two times. So I'm going to end up with 2 times negative 3x plus 16 over 9x plus 1. If you decide to distribute, you can, or you can just leave it like that. Okay, so again, we already know how to do these operations, so it's just coming down to simplifying it. So let's look at the last one. I have 5 over x squared minus 3 over x plus 1. All that over 4 over x cubed plus 1 over 2, or 1/2, minus 6 over x squared. I'm going to write my 1 as a fraction just so it's all consistent. And I'm going to try to find a common denominator. This time, I can't factor. I got x squared, x, and 1. But again, I need to get them to look the same. So I'm going to start with my x squared. My x squared already has a 1 in front of it. You don't see it, but you know when you don't see it, there's always a 1 there. And it already includes one of my x's. So I'm not going to touch my first one right now. My second one, my 3, already has a 1 in front of it. Again, you don't see it, but you know it's there. So it has the 1, that's good. But it doesn't look exactly like that x squared. What could I multiply that second one by to get it to look exactly like that x squared? And I could just multiply it times an x. Third one has the 1, but again is missing that x squared. So I'm going to multiply this one by an x squared. So I'm going to get 5 minus 3x plus x squared. All over, my denominator is just x squared. Okay, that's it. Let's look at my denominator here of my fraction, 4 over x cubed plus 1/2 minus 6 over x squared. Again, start with my first fraction. It's x cubed, so it already includes my x squared. My x squared is already in x cubed, so it includes that. But it is missing that 2. So I'm going to multiply top and bottom by 2. My 2, let's see, doesn't have the x cubed, so I'm going to multiply top and bottom by the x cubed. And if I do that, that means again my x cubed already includes my x squared, so that's taken care of. My x squared is missing that 2, and since I need it to look like an x cubed, I'm going to need to multiply it by a second x. So now my denominator is just 2x cubed. My numerator would be 8 plus x cubed minus 12x. Okay, so let's go ahead and see if I can divide these. So I have 5 minus 3x plus x squared all over x squared divided by 8 plus x cubed minus 12x all over x cubed. So when I divide, I want to flip and multiply. And I'm going to write this in descending order just so it's prettier. X squared minus 3x plus 5. I'm going to check real quick, make sure that can't be factored. It can't. Over x squared. That's going to be times x cubed. Again, I'm going to write it in descending order. So x cubed on the bottom minus 12x plus 8. I'm going to check and make sure that can't be factored. Only cubics we know how to factor are perfect cubics. This is not, so I can't. So the only thing I can cancel is my x cubed and my x squared, leaving me with an x on the top. So my final thing should just be x times x squared minus 3x plus 5 over x cubed minus 12x plus 8. And that's it. Okay, so we're going to look at one other way to do these on the next one, but hopefully this made sense.